Hi everyone, welcome to your favorite learning channel. This is a short video explaining how a plus b whole squared, which is a basic identity in algebra, gives you this value as this value from the graphical perspective. Right? This is a bit counterintuitive in the sense that when I would think of a plus b whole squared, why won't I see just these two quantities and what is the relevance of this? How does it come? We will see this. We've seen this in an algebraic form. We will see this in a geometric form now. Remember, some of the basic things is if you have a rectangle or a square, right? Area of that rectangle or square is calculated by multiplying its length and breadth, right? In case of square, length and breadth are same, so you just square them. But in case of a rectangle, you multiply them, the length and the breadth, and you get the area. Now, let's assume this is a square of side A, right? What is the area of the square? A times A. A times A is A square. Now, if I add, this is original A square, right? If I add another quantity on this is A. If I add another quantity on this and I call that B, this part is B, right? What would be the whole square of that? So this entire value is A plus B. Now, okay, how do you calculate the whole square of this? This is already A. Now, in order to get a whole square, you need to form a square of the side. Like you have a square of A, you need to form a square of this size. How do you form? So this size we already have. We will form a square of this side. So this will give you an additional quantity of B here. So this is B and this remains A. So what we have seen is these are, and let's connect it this side, this way. So what do you see here? This quantity is A. Remember, this is B, so this is a rectangle, so this will be B. So this will be B, and this will be A again. This is B. So essentially now we've got a larger square, which is A plus B whole squared. But the area is 4 components. You have this A, which you already had. And then you have 3 more components that have been added because of adding this quantity on one side. We are looking for, remember, we are looking for A plus B whole square. So a square of the size A plus B. What are the 3 components? That is in addition to what we already had. So this is B times B. This is B as well, remember? So this is B times B, this is B squared. And then you have B times A. That's BA. And you have A times B. That is AB. Now you get A squared plus B squared. AB and BA are same. Right? So 2AB. This is the equation that you get here. And this is how you get it. So essentially, when we are doing a sum of square of a sum of 2 quantities, you can't just add the 2 squares, because if you add A square and B square, you'll just get this 2. But in essence, you should get these 2 rectangles as well. This is AB and BA. Two rectangles which are also additionally created when we add a quantity to an existing square needs to be added, and that's what is 2AB. Similarly, if you have a large square, which is A squared, let's say this is a large square and the size is A. You want to subtract a quantity called B. So let's say this is a quantity called B. So this is B. So when you subtract a quantity called B, you need to call a smaller square. Okay? So you will get a smaller square. So this is A minus B. Right? Now if you want to get a square of A minus B, you need to shorten both sides. So both sides need to be shortened by equal length. So this has to be B. So that this could be A minus B. So this entire is A. You've reduced B this much, which is the same as this. So this must be A minus B. So now we want to find the area of this smaller circle, smaller square. How do we do it? So A minus B whole squared should be equal. So the smaller square should be equal to this larger square, which is A square, A times A, minus this, and this. So from the larger square's area, if I subtract these three, I should get the smaller one. So what is the area of this? This length is B, we know. What is this length? What is this length? This length is A. Remember, sorry, this length is A minus B. So we take B times A minus B. Remember, this is A minus B, so this is A minus B as well. And this is B. So we've taken this area. We now need to subtract this area, which is minus B squared. This is B, and this is also B. What is this length? This entire was A, remember? You've subtracted B, so this is A minus B. So the area of this rectangle will be B times A minus B. And we have to subtract all of this. Remember, we are subtracting this, this, and this. We are subtracting three rectangles or three components from the larger square. We get A square minus AB plus B square. I'm just expanding using the straight process. Minus AB plus B square. Right? So if you see minus B square plus B square gets cancelled out, you're left with A square. This is minus AB and minus AB. So minus 2AB plus B squared. This is what we set out to prove. A minus B whole square is equal to A square minus 2AB plus B square. So this is geometrically, graphically, we understand how these algebraic equations or algebraic identities are derived. Okay. If you have any questions, please feel free to ask in the comment section. And also do not forget to like, share, subscribe, and click the notification icon if you like this is useful. Thank you very much.